Introduction to Hadoop. So, what is Hadoop? Well, Hadoop is a framework that allows for distributed processing of large datasets across clusters of computers using a simple programming model. It is inspired by a technical document that was published by Google. The word Hadoop does not have any meaning. Doug Cutting, who discovered Hadoop, named it after his son's yellow-colored toy elephant. So, what are some of the characteristics of Hadoop that overcome the issues we discussed earlier? Let's look at how Hadoop resolves the main three challenges of the distributed system, such as high chances of system failure, limit on bandwidth, and programming complexity. The four key characteristics of Hadoop that make it more useful are that it is economical, it is reliable, it is scalable, and it is flexible. The systems are highly economical as ordinary computers can be used for data processing. It is reliable as it stores copies of the data on many different machines and is resistant to hardware failure. It is easily scalable both horizontally and vertically. A few extra nodes help in scaling up the framework as needed. It is flexible, and you can store as much structured and unstructured data as you need to and decide to use them later. Let's compare a traditional database system versus Hadoop. Traditionally, data was stored in a central location, and it was sent to the processor at runtime. This method worked well for limited data. However, modern systems receive terabytes of data per day, and it is difficult for the traditional computers or relational database management systems, or RDBMS, to push high volumes of data to the processor. Hadoop brought a very radical approach. In Hadoop, the program goes to the data, not vice versa. It initially distributes the data to multiple systems and later runs the computation on whatever nodes wherever the data is located. Let's look at an analogy of a traditional system and Hadoop. We'll use the analogy of a tiger and a human being. You would have noticed the difference in the eating style of a human being and the tiger. A human eats food with the help of a spoon, where food is brought to the mouth, whereas a tiger brings its mouth towards the food. Now, if the food is data and the mouth is program, the eating style of a human depicts traditional RDBMS, and that of the tiger depicts Hadoop. Let's look at a few specific examples of a database system versus Hadoop. For an RDBMS, we have data types of structured, whereas Hadoop has multi and unstructured. RDBMS uses limited processing. The processing on Hadoop is coupled with data. For governance, on RDBMS, we have standards and structured data. On the Hadoop, we have loosely structured data. When we require a schema on RDBMS, we can have it on the write operation. The schema on Hadoop is required only on read operations. The RDBMS speed is very fast for reads. On Hadoop, the writes are very fast. The cost on an RDBMS is the software license. The cost on Hadoop often is support only. The resources utilized on RDBMS are usually a known entity, whereas on Hadoop, it can be a growing set of data, very complex and very wide. On RDBMS, the best fit use is for things like online transaction processing, complex ACID transactions, and operational data stores. On Hadoop, the best fit is data discovery, processing large or small amounts of unstructured data, and massive storage and processing. So what are the Hadoop core components? Well, there's three: processing, resource management, and storage. Processing of the data is done by frameworks such as MapReduce or Spark. Resource management is done by a cluster resource manager called Yet Another Resource Negotiator, popularly known as YARN. Storage is done by Hadoop Distributed File System, also called HDFS. These three components of Hadoop are closely connected.